Okay, is anyone out there? Hello? Hello. So live streaming as of now. So I hope people are out there. I'm just going to pop a message up, see who's there. Where's the further mask close, further mask close. Live stream is on. So if everyone could just pop in. Oh, that's brilliant. I've got one person. Can you write your name in the chat box for me so I know who I'm talking to? Oh, I've got a message. That's nice. So live stream is on as of now. No one saying that. Obviously, if you're on the live stream, you know the live stream is on. I'll just wait up for you guys and I'll explain to you what we're going to be doing today. I'm going to be on for quite a bit today. It's a nice long live stream, this one. Say hello to everyone. I hope nobody's got corona. Come on, dude, don't got one bloody person on it. If you are the one person watching this, can you put your name in the chat box so I can like literally kill everyone else from not turning up to live streams? Oh, it's Kelvin. Hello, Kelvin. You come to a lot of my live streams. I really like that. You're super good at live streams. Can everyone else get their act together on this? We've got two people. Kelvin, you are the first. Xing, brilliant. We've got two people. Xing, if there's a group chat, can you pop it on the group chat that we're on this? I've already put it on the the Microsoft Teams. And this is tedious, isn't it? Oh, Eman, brilliant. That's good. So I've got two people, but apparently I've got Xing, Eman, and Kelvin. So you know what? I'm going to wait for a few more people to come up. I hope everyone's well. Is that mechanics? Mechanics is what we're doing. Yes, you're absolutely right. It's going to be page 146 in the textbook. So can you open up for me the Applied 1 textbook? I'll write all of this down on the whiteboard. Don't worry. Also, we're going to start using Dr. Frost again for homeworks because I tried marking the the stuff you're sending me via camera and it's like absolutely horrible. Okay, so what are we doing? Page 146 from Mech 1. I'm sorry, not Mech 1, Applied 1. So you can't see that, I apologize. It's page 146, Applied 1. You hate Dr. Frost. I mean, I do too, but I just can't mark your photographs. Why has it gone down to 2 people online? Now I need to do some bloody teaching it, my dudes. I know I was a little bit late on it, but that's because I was running a mock exam. Online mock exam is no fun. How am I, VJ? I'm fine, thank you, Eman. I hope you're well too, and I hope all your families are well. For once, I'm not taking the mickey. You don't have a phone right now. Okay. You don't need a phone. Presumably, somehow you're on the live chat. Whatever. I'm not saying you have to go to Dr. Frost right now. We're not going to use Dr. Frost right now. Dr. Frost is only for homeworks. All right. I'm going to be live streaming like a lesson, right? Because obviously trying to do stuff just by doing PowerPoints that you didn't work. So I'm going to teach every lesson like normal, just instead of it's in my house, right? Reba, I hope you're well. Hope your family is well as well. Take care, right? I don't want any one of you dying. I mean, we don't always see eye to eye, but I don't want any of you dead. So, let's do this. Let's start. So yeah, I'm going to be live streaming for about half an hour to 40 minutes today, talking about the chapter 9.5 in the Applied book. So 9.5. I'm going to give you a minute or two just to get the book up. I will send you emails with a PowerPoint on it at some point. And Eman, I will get my act together and send you a few more books as well. That will happen very, very shortly. But for now, I'm going to say about a minute's time, I'm going to start teaching. What do you need to do in the next minute? You need to check that your Dr. Frost works if you haven't done that already. Don't need it for today, but I'll be setting homework from it soon. You need to have the Applied book open to page 146, 9.5. So either have it on tab if you've got the online version or have it physically to hand. And I'm going to start teaching in about 40 seconds. And the thing about it is I'm going to be referring to examples specifically. All right? I've shared the PowerPoint. Oh, you are a legend. Well done, Eman. You are a blessing. As it stands, I'm not going to refer to any of the PowerPoints I want to teach. Do you know what I mean? But if you look at chapter 9 mechanics, the PowerPoint might help you after the lesson. All right? So I'll never refer to lessons, like PowerPoints in lessons, until like after half term. After half term, so after Easter, I might start using things like Google Classroom. But I like teaching and talking and teaching and, you talking back to me. Because I don't think you can really, just set a PowerPoint and, that's not really teaching, is it? Okay, so everyone's here now. So what are we looking at? I'm going to start by taking you through exercise 9E, and the topic, and that's found on page 151, okay? And the topic we're talking about is vertical projection. So things being tossed up in the air. Now for first year, either you're dealing with something that's moving horizontally or dealing with something that's moving vertically, but never both, all right? You can use Google Meeting. Yeah, I mean, I'm going to start looking at that. Basically, what I'm going to do is over Easter, I'm going to learn a lot of those skills. I honestly don't think what I'm doing is too bad. Yes, it is possible to use Teams. In terms of, okay, the good side of Teams is you guys get to talk back to me rather than type. The downside of Teams is I don't have full control. I don't know if you figured this out yet, but you can easily, people can mess it up. And I'm not saying that's a bad thing. I don't think you guys would mess it up. But like, you can mute each other. Like I was in a meeting yesterday, I got bored, I started muting my colleagues. I mean, it didn't end well, but you know. So it's not as, you know, it's not as the teacher doesn't have the power as much as they want to. And I'm someone that I'd rather, you know, I'd rather use YouTube. Also for my own sake as well, for YouTube, because that means the lessons are here forever. So if you want to go back and look at this 6 months down the line, you can watch this video again and remember the time we were all stuck here with coronavirus. I mean, for presentations, yes, I'm actually going to use Google Classroom or Teams for presentations. I'm not going to do this before half term. I want to just teach this way until Easter. And then after Easter, I'm going to start showing presentations. But for now, I hope this will make enough sense to you that you're going to be fine with it. So let's just do this for now. You can record your class on Teams. Again, yes, you probably can, but I need to learn how to do that. All right, cool. There seems to be 11 people watching this, which is mad because there's only 8 of you in the class. I'll look back in later. Okay, cool. Until Easter, we're always going to be at YouTube. After Easter, I'm going to take up some of the advice that Eman and Kaisan are offering with regards to doing things on maybe Microsoft Teams or Google Classroom. All right. So I'm listening to what you're saying. I'm respecting your opinion on that one. I will try those things out. And if they're better, Steve, Greg, and Mark, beautiful. Mark is spelled with a C because he's a Frenchman. All right. Be careful about that because Mark is Francais. Okay. And he'll be offended to be given a K at the end of his name. Anyways, let's do exercise 9E together. All right. So page 151 in the applied book, 9E. All right. And I'm going to write out the question for you. It says a cliff jumper. So cliff diver. So here's a cliff diver. Here was a stickman. He's diving off a cliff. There's your cliff. And he jumps from a point 28 meters above the surface of the water. So this distance here is 28 meters. And what you're seeing is what you should always do with any kind of mechanics question is always just start with a picture, right? So 28 meters, right? Modeling the diver as a particle. So he's a particle. What does that mean, calling somebody a particle? It means, sorry, you can't see that. And this will probably be one of the good sides of using something like Greg uses, because you can do some online things. Anyways, modeling someone as a particle means that you can completely disregard air resistance, all right? So air resistance, friction, all of goes out the window. Can somebody tell me the only force that's acting on my little cliff diver here? Pop it in the chat box. Tell me what force is acting on the diver. So type in the chat box what force you think is acting on the diver, given that I told you that air resistance isn't going to be there because that's right, it's gravity. Yeah? So gravity is acting on it. And it's going to be acting with force of mg. And you're actually not meant to know that yet, but I'm just going to let you know. Where m is mass and g is gravity constant. Anyone know what the gravitational constant is? You want to put that in the chat box for me, what the gravitational constant is? Air resistance is not allowed because we're modeling it as a particle. The reason why we don't use air resistance, Kaisan, is the mathematics behind air resistance is hardcore as hell. It's called fluid dynamics. Reba, I was hoping you were going to say that. In maths, it's 9.8. Okay, and you will actually lose marks if you use 9.81. So I was hoping a physicist would come back and say 9.81. It is 9.8. Eman's right, and I'll tell you for what. It is actually true that gravity isn't constant over the face of this Earth. Okay, it's a true fact. There is a place in I think it's Wookey Hole, but I'm not entirely sure. I don't know where Wookey Hole is, but I've told this is a real place. Okay. where gravity actually is not as powerful as it is in other parts of the world. Not a huge amount. We're not talking about like you'll be able to like do kind of like moon bunny hop thingies. That's not what I'm saying. But it is enough to say that if you do the average gravity all over the world, well, Bermuda type, let's not get into that. What I'm basically trying to say to you very, very simply is that gravity is not a constant 9.81. It varies across the face of the Earth. And all the numbers it varies to round up to 9.8, so we use 9.8. There's nothing to do with gins, my dude. But it will kind of make a bit of sense, wouldn't it, really? You know that gravity works under... Right, I'm just talking directly to physicists, right? So the rest of you guys is going straight to your head. You know gravity is what? Inverse? Is it inverse square or inverse cube law? Can't remember. So obviously, the further away you move from the Earth, the less gravity will be affecting you. So obviously, if you're living in, say, if you're standing on the top of Mount Everest, I suppose there'll be a difference there. But more than that, right? Gravity is a function of mass, right? Because it's mg. So if you've got less dense material, I guess, I don't know. Anyways, right? All I've got to say to make that explanation is just say, gravity isn't 9.81 just like they told you. It varies over the face of the Earth. So I'm hoping that makes sense to you, right? That's why it's 9.8. Before, I used to just think that maths was lazy, but I actually spoke to a chief examiner and he explained that to me. All right, so that's why. Anyways, we've got sidetracked with the question. So I apologize for that. And the question asked me to find how long does it take for the diver to hit the water and the speed of the diver when he hits the water, okay? And those revolve around you knowing Suvat equations. So can I ask you guys in the chat box to write down all the Suvat equations you know? And if you don't know any Suvat equations, we're going to spend a few minutes teaching you Suvat equations, all right? So can you type in the chat box all the Suvat equations you know? And if you don't know what a Suvat equation is, can I hear a question, like just say, I don't know what a Suvat is. Put it in the chat box for me. And I'm waiting on you to do that. Is Farhan here? I've got 6 of you. I haven't got Farhan, and I haven't got... Who am I missing? No, I've got Thingy. I've got Zaraf. So it's only Farhan. What is Suvat? Thank you. So Suvat are a set of 5 equations. Now, like that physicist again, you're going to complain. There's only 4. There are 5 for maths. There are 5 equations. Not Kelvin's law, annoyingly. Kelvin's law would have something to do with temperature, surely. Kelvin's here. He was literally the first one on the live stream. There are 5 equations that connect 5 variables. I'm going to write them down for you on this side. So you've got V equals U plus AT. And even if you don't know what they are, can I ask you just copy them for the time being? Then I'll explain what they are. S equals UT plus a half AT squared. S equals VT. Oh, thank you. I mean, you probably did us a huge favor here because there's probably... Whoa, sorry, you can see my house. Because there's probably other people that don't know it, but will be too scared to ask. So thank you for doing that, Iman. I'm appreciative. All right. And V equals, of course. Yeah, but you know what? You say that, but you don't want to take risks on people's knowledge. So can everyone just copy them down? Even if you know what they are, can you just copy them down so you're going to need them today? And you might be thinking, what the hell is VUSAT? And I did explain that last time we saw each other. But I'm happy to, we're going to go through this. We'll recap Suvat, okay? So make sure you, whatever happens, you copy down those 5 formulas because that's what you're going to be using throughout today, all right? And then I'll explain what each letter is once you finish copying it. So as soon as you finish copying it, again, in the chat box, the biggest thing I'm going to say to you until I abandon YouTube, and to be honest, my heart doesn't want to abandon YouTube for 2 reasons. I like the fact that, everyone can see my lessons and, my normal maths can come and, they can see all this stuff and that's good. I also quite like the fact that my subscriber count and my video count is going up. I know that sounds incredibly, childish, but I do enjoy that. I do check my my subscriber thing as well. So, do we do exercise 9E? Yeah, eventually, but we want to talk it through first, right? That's what you're getting taught today. Is the last one the new one? The last one for you for physics, you don't get VT minus a half AT squared. I think Suvat is Suvat. Suvat is Suvat. True. Tautology. Will these be in the formula booklet? Yes, sir, but you need to be able to prove them. okay? And proving them is a whole nother lesson, which we're going to be doing on Monday. For now, let's just play with them. We've got this new toy, let's play with it, okay? So yeah, formula booklet, they'll be given, but they won't ask you, what's the Suvac formula? They go, here's a Suvac formula, prove the damn thing, okay? And you do it from graphs, and again, that's going to be a big chunk of Monday's lesson, all right? So has everyone got these formulas written down now? I'll give you about another 10 seconds to get this copied out, then we'll move on, and I'll tell you what, basically, I'm just going to talk to you about what the letters are, because that's important too, because you don't understand what the hell's going on. All right, so hopefully you've got those formulas written down. You can look them up as well. So what is S? S is your displacement, and displacement is just how far you've moved. U is your initial velocity. People living in my house must be getting, like, literally getting free A-level tuition. V is final velocity. A is acceleration. And the thing about Suvac is acceleration has to be constant. There is something called variable acceleration, which comes, we've covered actually already once, but we'll cover it again, where acceleration isn't constant. And if acceleration isn't constant, you can't run Suvac. And T is time, all right? So again, copy these out. I'll give you about a minute. Then we're going to use Suvac on the guy falling off the cliff or jumping off the cliff because he's crazy. I mean, why would you jump off a cliff? I mean, I get a cliff diver jumps. I mean, you got better things to do with your life. I mean, anyways, not for me to discuss. So you've got, I'm going to give you about another 30 seconds. Copy SUV80 in your notes, please. The definitions thereof. Then we're going to do the question together. All right? God, I'm tired. I don't even know what I'm tired by. I hope you all guys maintaining lockdown as much as you can, all right? Don't want anyone getting ill. That would not be a good look for any of us. Don't worry, I haven't got corona. Right, okay, I'm going to rub this out now. So displacement, initial, final, acceleration, time. So let's apply this. Let's do a question. We're going to do the question with, it's always the other way around, isn't it? Yep, there we go. So here's our guy. Here's our dude. He's jumped off a cliff, literally jumped off a cliff. And it asks us, how long does it take for this guy to hit the water? All right. We know what. So I'm going to start filling in the Suvac for this. We know what. We know that S is 28. He's traveled 28 meters. U, oh, I've got a message. So U, they tell you the initial velocity is 0. So if you're struggling to tell what question we're doing, it's 9E, page 151. V, no flipping clue. Not the foggiest. Acceleration is 9.8. The reason why this is the way these are both positive, because we're going down this way, and obviously gravity acts downwards, and T is another thing we don't know. Okay? And the question basically asks us, can we find the time taken? So we need to find an equation that's got S, U, A, and T in it. All right, because they're asking us, find the time taken for the diver to hit the water. We need a SUAT equation. All right, and let's see if we can find one. Well, SUAT equation, let me just find a thin pen. What's people's favorite color? I've got loads of colors. I mean, lucky enough, I bought this before lockdown. Let's go with the purple. Nothing wrong with a bit purple. So S equals UT. Oh, that's beautiful. I hope that keeps working like that. S equals UT plus a half AT squared. That's the one I'm going to use because I've got S, U, A, and T. It's the only one I can pick to find time because it's got the 3 numbers that I know and the thing I'm looking for. Obviously, that's going to be a quadratic. So let's just substitute numbers in. You get 28. UT would be 0 times 9.8, doesn't exist. A half AT squared. So it'd be 0 times, yeah, so 0 times T, so that wouldn't exist. So this would be a half times 9.8 times T squared. And I reckon you can solve that. I'd like you to give me 2 solutions for that, please. Okay, one of them would make sense under context and the other one wouldn't. All right, so can I ask you just to finish that and tell me what T is? And that will be question 9E, part 1 done. Someone's just sent me an email about someone bunking the year 13 more. So I'm just going to read that for 10 seconds, not out loud. So 2.4, 2.39, brilliant. Let's just check that. Obviously, there's a plus or minus. The minus doesn't make sense. Why? It's a really stupid question to ask, but I'm going to ask it anyways. Why don't I care about the minus 2.39 or the minus 2.4? Pop it in the chat box. Why don't I care about the negative value here? Well, sometimes you do have to care about negative values, but why don't I have to care about it now? So what's this 9e we're doing? Yep, 2.4, 2.39, brilliant. Good job, good job. You've worked out 9a and 9e on Teams. Okay, Iman. I will think for you then. Do you want to try mixed? Have a crack at mixed for me, all right? Because time is in the air. I mean, we're not going backwards through time, as much fun as that would be, all right? So let's have a look at part B of this question. Cool, well done. I'll have to find him different questions for next time if he's done bloody textbook. Never mind, I'll catch you next time, you know. Okay, B. The speed of the diver when it hits the water. So this time I want S, U, V, and A, not T. So I'm going to go with V squared equals U squared plus 2AS. Even though I know what this is now, one good rule for mechanics is this, right? One good rule for mechanics is this. That if you do a calculation in part A, don't rely on it unless you have to. If you have to, use it, yeah? But I don't have to here. Because imagine if I got this wrong. We know we didn't because we checked the answer. But imagine we got this wrong. And then we fed it back into part B. We'd get another mistake. All right? Is that making sense to you guys? So that's the reasoning why I'm going to say to you, never reuse a piece of your own working unless you have to. And if you have to, do it. Okay? So here we've got V squared is what we're after. So V squared is question mark squared. U squared is 0 squared. 2 times A times S, okay? And then you can work out what question mark squared is, which is what the V squared is, right? So does that seem reasonably simple to everyone, right? So we're just going to use Suvat to basically work out the things we're looking for, all right? Now, the exercise 90 has 13 questions in it. I don't want to go offline after 20 minutes. I don't feel like that's proper teaching. So what I'm going to ask you to do is I'm going to ask you to do question 2 and 3 while I'm online, and we'll have a discussion on it. But I want you to do it this time, okay? So I want you to do question 2, pop a solution in the answer box, and we'll chat it through. Do question 3, pop a solution in the answer box, we'll chat it through. Once we've got past question 3, then I'm going to leave you to it, because at that point you should have fully understood it, right? So if anyone's got any particular problems, drop me a message. I'm going to be on. I'm going to be probably chatting nonsense because I can't bear to have silence, as you know from my teaching. So what I'm asking you to do now is do question 2 and question 3. Just to give you clarification on what the answer for 1B was, so you can test whether you got it right. 1B is 23.4. Okay? So 23.4 is your final velocity. All right? So what I want you to do is to do question 2 and question 3. So people are only free right now. Yeah, sorry. It's like literally everything is going on today. But I'm with you. Right, so question 2 and question 3 needs to be done. You need to start popping them into the answer box as soon as you've done them. If you find yourself struggling, pop a message in the box saying, I can't do this, I'll walk you through it. Haven't heard anything from anyone for a bit, so I'm presuming everyone's trying number 2, right? So we're down to 6 people on this. So someone's dropped out. I've not said drop out. I want to see you actually doing question 2 and question 3. Thank you, that whoever came back. I want people doing question 2 and question 3 and submitting answers. I don't want a 20-minute live stream for an hour and a half lesson. That's okay. So question 2 says, find the time of the. Are you doing 3? What are you doing? Reba, I'm confused. Find the time of flight of the particle. Yeah, no, okay. So it's basically how long does it take from being displacement 0 once to being displacement 0 again? Yeah? Okay, cool. So I'm just going to draw you a little picture, all right? Pictures help. So you start from here, yeah? Whoop, whoop, yeah? So the time it takes to get from here all the way back down to hitting the ground again. No worries, my dude. I'm here to teach you. I just realized you can't see any of that drawing. So let me just put the drawing somewhere we can actually see. So it starts like this, goes up, and comes back down again. All right? So it's all the time it takes from leaving the Earth to re-landing on the Earth. That's an interesting question. What would we know about the velocity here at that point? You can't see it all that well. I'll put it here. Is there anything we could say about the velocity at the highest point of the curve? Yes, absolutely right, Rebut. So can everyone take that on board? Rebut tells us that at the very highest point of its curve, so it will be a parabola generally, the gradient will be 0. Thank you, Farhan, you got that as well. Brilliant, sir, well done. So just be aware that if you throw something up in the air, its highest point would be 0 when its velocity is, its velocity is 0, got hiccups. The reason is, after that point, the velocity is changing direction. Well, yeah, the velocity is changing direction, and it's starting to hit the Earth again. $4.1 for the second one. Let's have a look. One thing that Rebut's doing, and I know it sounds like it's let's praise Rebut Day, but I think Rebut deserves some praise, is have you noticed these answers are always given to 1 decimal place? And the reason why that's right, and I don't know if that's the reason why you're doing it, but it's the reason why you're right, is because you're only giving gravity as 1 decimal place. You can't be more accurate than your worst ingredient, if that makes sense. Your worst ingredient here is gravity, which is 9.8. Okay, you don't know how to do this. We're going to do it together. Let me just check. Yeah, 4.1 for Rebut. So let's do it together then. All right, let's do this one together. So let's draw a little picture first of all. So here's the ground. Particle is projected upwards with speed 20 meters per second. Find the time of particle. So basically, how long does it take to get to its highest point and then fall back down again? So how long does that take? All right. So what I'm going to do is do the SUVAT directly beneath it. SUVAT. Yeah. I'll move that down to teensy bit so you can see all of it, right? So what are we saying there? Our displacement is 0 because it's going to go up in the air and land back down onto the ground. Okay. So the distance it's traveled, it's gone up and gone down again. But once you consider from here to there, how far has it moved in the vertical direction? Nothing. Yeah. It's gone up and it's come back down again. And vertically, at least, it stayed the same vertical height. Okay. But yeah, hopefully, I mean, it was something that was worth saying about. Yeah. U is 20. How do I know that? Because my initial velocity is 20. Now, one of the most common mistakes you can make here is assume when it hits the ground that V is 0. It might be 0 a millionth of a second after it hits the ground, but it's hitting the ground with some velocity. If it wasn't hitting the ground with any velocity, it will be flat. Yeah. So we don't know what V is. And a lot of people make that very, very simple assumption that things are hitting the ground, so therefore, they've stopped. And they will stop eventually, but not right there. I'm coming to that in Morello. Just check that second. The acceleration is minus 9.8. Now, here's the difference, right? I've decided to go, well, positive is up, yeah? So I'm starting at 20 meters per second positive. So gravity is going down, so I have to put that as a minus 9.8, okay? So gravity is acting this way. See, double arrow means you are a acceleration. So if you ever get a double-headed arrow like that, so two heads on the arrow, that means you're basically saying that this is acceleration. So if this is positive, that must be negative. And the time is what you're looking for, okay? So it's a Suat equation. S equals ut plus a half at squared. Yeah? So ut, so you've got S0 equals 20t. Well, it'll be here minus a half times 9.8 times t squared. And the easiest way to deal with an equation that equals to 0 like that is just factorize a t out. So t 20 minus a half at squared, so that will be 4.9 t, all right? And that equals 0. So either t equals 0, which you already knew. You can't see that, so I'll put it here. Either t equals 0, which is something you already knew, or this equals 0, 20 minus 4.9t equals 0. And you can solve that as an equation and find out what t is, which I presume is 4.1, all right? So that's how you deal with that one. So I'm just going to answer question 3 just to make sure Mirella and Reba are happy with the fact that I think they've got it right, but I'm going to check. What was this? 9e. Yeah, 9e. So 9e, 41. Yeah? Now this time it's Mirella's turn for praise and Reba's turn for criticism. Not that it's going to be big criticism. Mirella spots correctly that 9.8 is two significant figures. And therefore, if you go to Reba's 41.3, you've got 3 significant figures. Therefore, your answer is better than your ingredient under Reba. Mirella quite rightly thinks, well, that's not logical. If I've only got 2 decimal places of accuracy for gravity here, I can't have 3. Sorry, if I only have 2 significant figures worth of accuracy here for 9.8, I can't have 3 significant figures worth of accuracy for 41.3. So this time I'm going to be praising Mirella. All right. So all of you guys, I hope, are taking on board that lesson about accuracy. Whatever ingredients you put in, the worst accuracy that you've got there is your bound. All right. Anyone got any further questions on this? Anyone want to see 3, for example, or whatever? Because I'm still here. So I'm going to hang around here for a couple minutes. So I haven't heard anything in the chat. So you've got about another minute to make a complaint. Anything else you want to have explained? Otherwise, your work is literally finished 9e. Send me the pictures. Your homework will be set on Monday in Dr. Frost. So over, as well as whatever homeworks I've set you, your last piece of homework is just to check your Dr. Frost account still works. All right. So you've got about another 40 seconds to say, stop, I need you to teach more. And that's fine. I will do. I've nothing better to do. What's the homework? If I didn't set you any homework already, I just want you to go onto Dr. Frost and make sure that works, because I'll set homework on Monday. I'm pretty sure I would have done. But if I didn't, just take it as here's an early Easter present. Okay, and I'll set homework on Monday. Mainly because I know exactly what I want to set. I want to start getting the habit of Dr. Frost. Can you send email for Dr. Frost? I forgot how to log in. Absolutely, I can. In fact, can you stay on for the minute while I do that right now then? So yeah, I mean, this might be the last thing we do today then. Let's go to Dr. Frost, anyone who hasn't already. So just waiting for this to... Dr. Frost is actually now messing up on me for some reason. Okay, cool. Got it. Year 12 FM. Okay. Okay, Kai-san, this is how it works. Can I send you a direct email? Let me see if I can figure that out. I might be able to, you know. Let's see. Edit. No, I can't send you a direct email, but I can tell you exactly what to do. So if you go to use your college email, including FE, I'm sorry, not FE colleges, student.candy.ac.uk. Yeah, I'll write that down. So it's the one that ends your SOID and then student.candy. You can't see any of that. Let me rub this all out. So it's your SO whatever. You still can't see that. Why am I stupid today? Don't answer that, guys. At student.candy.ac.uk. Now, what's your password? I hear you ask. Well, you didn't ask, but you might have asked. Your password is password because I've just reset it for you. Okay. Awesome. So, can you test that now for me and see if that works? I'm pretty much done here. Okay, so try your Dr. Frost and then we're done. You can get about your work. If you know your Dr. Frost is working, in fact, I can check right now who's been on. Eman's done it in the last 2 days, but no one else has logged on in the last 6 months, which is a bit worrying, but yeah, to be fair, why would you? So I haven't been setting stuff on there. Kai-san's works. Yes, you might want to check that. Just make sure that all works for you. Okay, I was going to check comments if anyone's got any. Can you quickly set something to see if it works? Okay, cool. I can easily set something. I'll set the homework that I was going to set for Monday. So it's not you have to do it early. It's just going to be there. Set work, set homework, automated homework. Let's just do an integration one between. That's a good one to set, I think. Pure maths, integration. Let's do integration by parts just for the hell of it. Preview questions, 10 questions, fixed number of questions, 10 questions. Right here. So set task, good. No class selected, so my apologies. Set task for you guys. The further maths. Okie dokie. Oops. It's not as easy as it looks, you know. Select all. Okay, and then set task. Okay, so you've now got homework being set. I haven't put a date set for it. Maybe I should change that up. Can I change that up? Okay, cool. So yeah, it's open and it's due for next Monday, not 7 days now. You can see it, brilliant. Okay, cool. So I think that will call that to a close here. Everyone try your Dr. Frost. Your homework isn't due for this Monday, it's due for the Monday afterwards. So you've got 10 days to do it. In fact, it's Easter, so make it next Thursday then. All right, so you've got a week to do it. Okay? So everyone's got homework set, and it's due in a week, which is loads of times, 10 questions. You do one every day, practically. All right? Unless anyone's got any further questions, we are done here. Have a lovely day, weekend, and take care of yourself. Reba, anytime. Any other questions, let me know via Microsoft Teams. Here you go.